All right, and that's gonna give me my decimal answer. So my decimal answer, I'll type cosine, second sine, 1 divided by 3. So what did we get for our decimal answer? 9428, that's exactly right. That's my decimal answer, 0.9428. All right, now when we do this problem by hand or exactly, exact means no calculator, it means we're going to do it by hand. We're going to draw a picture. We're going to draw a picture of a triangle. And this is the triangle we're going to draw. So which quadrant am I going to draw that triangle in? The first. And how do I know it's the first? Positive number. I will tell you where to draw it if it's not positive. Now, what do I know about this triangle? I know the sine is 1/3. So what's the 1? What's the 3? 1 is opposite, 3 is hypotenuse. What do we always do when we, I mean, every time we end up with something like this, what do we always do next? Find the other side using the Pythagorean theorem. So x squared plus 1 squared equals 3 squared. Remember, when you do the Pythagorean theorem, the equals 1 is the hypotenuse. So x squared plus 1 equals 9. X squared equals 8. So x equals the square root of 8, which is 2 radical 2. The square root of 8 is 2 radical 2. Usually we get something like 13 or something and it doesn't reduce, but radical 8 does. All right, now ready to answer the question. What's the question? Cosine? What's the cosine of that picture? Here's your angle. Have you worked it? What's the cosine? 2 root 2 over 3. So again, that is a 2-part question. We are going to do it on our calculator, which is so easy. Just type it in. And then we're going to do it by hand by drawing a picture, doing the Pythagorean theorem, and figuring out sine or whatever this is. Now we have our word problems. I told you the other day, I think, that the test does not have 5 word problems. There's 5 on here, but I think the test only has 3. This is just extra practice. So here we are, problem A. We got the squirrel in the top of the tree, looking at a nut on the ground. Right? The next chapter. Okay, so what's what? I need to put all my numbers in here. So what'd you say? Height is X. Find the height of the tree. Angle is 17.7. I don't even have to think about that because isn't that where I always put my angle in these word problems? So there's no confusion there. And where's the 52? The nut is 52 feet from the squirrel. So I heard Ed say hypotenuse, is she right? There's the squirrel, there's the nut, 52 feet away. All right, what's my equation? Sine, because sine is opposite over hypotenuse. Is this gonna be a second sign problem? No, that's only sine x. This is not sine x. So I'll multiply by 52 to get rid of my fraction. And that will be the answer to the question. 52 sine 17.7. Did you get 15.81 feet? You need to ask if you have a question. Are we good on that? Everybody get all that? Now we got a fish in the water. Here's my fish. Because my seagull's sitting up here looking at the fish. All right, so somewhere I have to put the 100. Here's the seagull looking at the fish. Somewhere I have to put 100. Somewhere I have to put 12. And somewhere I have to put X. So what do you think? 100's on the bottom, exactly. Because the fish is 100 feet from shore. All right, where do I put the 12? Right here? Where do I put the X? It's the angle. Okay, we know what that means, right? So here we go. Sine, cosine, or tangent? Tangent x equals 12 over 100. Right? All right, how do you type that in on your calculator? Second tangent. I see an awful lot of no lanyards. You people are all getting in fractions. So this is going to be second tangent 12 100ths. I got 6.84. And that would be degrees. Always put a unit on your answers in the word problems. That one's going to be degrees. All right, anybody have a question about that one? All right, now we have a plane coming into the airport. So somewhere I need to put an X, a 7,000, and a 235. So tell me. Hypotenuse is 7,000 because it says the plane is going to land at a point that's 7,000 feet away from him. Okay, I got that. Where's the 235?
The height, so the opposite.
That's how far he is above the ground.
And the x is the angle.
And the X is going to be the angle. As it says, find the angle. Sine, cosine, or tangent? Sine X. There it is, sine X. You know what that means. Equals 235 over 7,000. So X is going to be second sine. Ooh, I got 1.92 degrees. All right, 2 more, and then we'll do whatever problems you want to do. These last 2 done. We got a flagpole. I need to put a 16.62, a 64, and an X into the problem. 16.62 is at the bottom. Does everybody understand that? We've talked about that before. That is the shadow. And where do shadows appear? On the ground. Always. Alright, where do I put the 64 and the X? The X is the height of the pole, and the 64 is the angle. Everybody okay with that? Sine, cosine, or tangent? Tan 64 equals X over 16.62. Guys, what's your answer? Well, how do I solve this equation? Multiply by 16.62. Don't do anything else, that's it, that's all you have to do, 16.62, tan 64, 34.08. Good on that one? Alright, one more. Alright, now we got building. And the man looking at the building. Somewhere I gotta put a 48, a 3,000, and an X. So what do you think? 48 is the height of the building. 3,000 is where? Bottom. Let's read this problem a little bit more carefully. If it said he's standing 300 feet from the building, or 3,000 feet from the building, that's where the 3,000 would go. But what does this say? He's standing 3,000 feet from where? The top of the building. So doesn't that 3,000 have to go here? So let's talk about that one more time. This problem specifically says, here's the man, he is 3,000 feet from the top of the building. That would be this distance right here. Normally, the problem says he's standing 3,000 feet from the building. If we're just standing 3,000 feet from the building, it goes here. Do you see the distinction? All right. Where's the X? What's the X? Angle. Sine, cosine, or tangent? Yeah, he's in this one. If he's teaching this period, that's where he is. Yeah. All right. So, what did you say we were doing? Sine. So sine X equals 48 over 3,000. So what do I type into my calculator? Second sine, 48 over 3,000. Gertrude, you want to put your head up for me, please? I'm afraid you're going to fall asleep and miss some of this excitement. Did you get 0.92? So that's a little tiny angle, about 1 degree basically, but that's what it is. Okay? Alright, that takes care of, now we've gone through completely 2 practice tests. We have 1 more, we're not going to get through the whole thing. So look at it, what do we need to practice? For you, what problem would you like to practice? on practice test 3? Because you know that's what your test looks like, so what are you gonna miss? Joshua, what's your hand up?
Yeah, number 5B.
Number which one?
5B.
5B. 5B, alright, says, and this is on the no calculator part. This is a no calculator problem, and it says, I'm on practice test 3, 5B, find the angle whose cosine is negative root 3 over 2. Remember, this means find the angle. Just like, remember on this problem right here, Joshua, when I used that button, what was I finding? An angle. So this notation always means find an angle. This is the kind that I will tell you which quadrant, unless it's positive. If it's positive, you put it in 1. I'm gonna tell you this one's in quadrant 2. So you're gonna draw your triangle in quadrant 2. We know that the cosine is negative root 3 over 2. So what does that mean about the sides of my triangle? Cosine is adjacent is negative root 3 and hypotenuse is 2. That's what cosine means. So you probably can tell that third side is 1. If you needed to, you could do the Pythagorean theorem to find that. But your job is to find the angle. So can you look at that situation and tell me how big that angle is? It's 30 degrees. Now, here's the tricky part. You can't say that the answer is 30 degrees. That's not right. Because if you're in quadrant 2, don't you have to be between 90 and 180? So we've got the right picture, but we need, not this little angle, we need the big one that gets us all the way around to that 30. So if that, okay, we have a 30 right here, can we figure out what that orange part is? 150. And for those of you that aren't getting 150, stop and think about it. All the way to here is 180. I didn't go quite all the way. How much farther do I have to go? 30? So it's 180 minus 30. That's a great problem, Joshua. Thank you for suggesting that. Does anybody else have one to look at? Something you might miss tomorrow. You didn't quite understand the first 2 times you did.
It's not a question, but would you specify on where to round on the test?
Yes.
Okay.
So, I know always on the ones where we're just typing in on the calculator, it's gonna be 4 decimal places. Pretty much everything else is gonna be to 100. But it'll say that on there.
You do number 3.
3 is another one that is gonna take a couple of steps to do because degrees, a radius of 6 centimeters, and I want to find that's actually arc length. The minute somebody says to me, find the arc length, I think of radius times radians. Now, you don't have to think that. Arc length is always radius times angle. That's what it is. The problem is, the angle has to be in radians. You can't do the multiplication if you're not in radians. So the first thing I'm gonna have to do is make this angle a radian. How do I do that? How do I change a degree angle into a radian angle? Yep, that's exactly right. Pi over 180 equals something over 125. Because 125 is my angle this time. So 180x maths for this?
Yeah.
Okay, so you're with me so far?
Yeah.
Okay, we gotta change our degree measure into a radian measure. Now, this does reduce. Sometimes they're easier to reduce. Remember, sometimes we have like zeros that we can just cross out. This one's a little harder. What would go into, if I were gonna break this down, what goes into 125 and 180? What common factor? 5? So let's divide 5 into both of those. To save time, I'll just do it. Those are common numbers, I just know them. But you could do 125 divided by 5 and 180 divided by 5 to get those numbers. That's what you end up with. Now, that is not the answer to the question though. That is this angle right here. So I'm going to erase the 125 and make it 25 pi over 36. Now I can find my arc length, because arc length is your radius times your radian. So once you get your angle to be a radian, then you just times it by the radius and you're done. Okay? So we use a couple different ways. One way is just to multiply straight across. I put my 6 over 1 so I can multiply straight across. Another way to do it is to cross cancel. Doesn't matter. Both of these are divisible by 6. So we're going to get 25 pi over 6. And that is the final answer. Now don't get confused, Gabe, because there's fractions in this problem. I know there's some fraction work, but that's not scary. We want to do radius times radians. These are great questions. Who else has one that might cause you confusion tomorrow? 24 hours from now, you're gonna be sitting here sweating. So let's eliminate something. Yes, Jocelyn. 4. Now, 4 is finding a lot of things. So, they tell me, however, that the cosine is 2/3, so that's a given. And because I know the cosine is 2/3, I know the secant is 3/2. Okay? So, Jocelyn, you with me so far? Okay. Now, what else do I know? I need some kind of a picture in order to fill those in. So what else do I know? Yeah, I know adjacent and hypotenuse, but when I go to draw my picture, I have to pay attention to this. What does that tell me about where I am going to draw my picture? Right here. Because isn't this 270 and this is 360? So here's my angle. It's between 270 and 360. The problem is right there written in the problem. So I know that adjacent is 2 and hypotenuse is 3. But we already looked at one of these earlier. This kind of picture came up in another problem. What do we always do when we have that? Find the Pythagorean, or use the Pythagorean theorem to find the other side. And we're going to be careful. 2 squared plus x squared equals 3 squared. Remember, it always equals the hypotenuse. So what is that x? What does that missing side turn out to be? Square root of 5? Negative? Remember when you draw your picture? If you're not in quadrant 1, something will be negative. All right, let's fill them in. Here we go. This is adjacent, this is opposite, it's hypotenuse. Sine, opposite over hypotenuse. Jocelyn, you with me?
Yeah.
Tangent, opposite over adjacent. Cosecant, 3 over negative root 5. Cotangent, 2 over negative root 5. Now, these two are gonna need cleaned up, but that is at least my first stab at everything. So this will be 3 root 5 over 5, and this will be 2 root 5 over 5. So think about, where are the pitfalls in this problem? Are there any? Are there any places where you might forget something? Yeah, exactly. I'll tell you, because I've graded a million of these, somebody's gonna forget the negative. You gotta pay attention to that. When you draw the picture, if it's not in quadrant 1, something will be negative. Another mistake that I see all the time is somebody will put 13, root 13, because they'll say 2 squared plus 3 squared. No, no, no. This is the equals number always. Anybody else? Come on. These are great questions. You're doing great. What else is gonna bother you? Calculator or no these have all been no calculator, which is fine. Is anything gonna bother you? There's graphing, there's calculator stuff. What's gonna bother us on our test? Which one? 6. In which quadrant? So the answer to this is going to be either 1, 2, 3, or 4. You gotta figure out which quadrant this happens in. And you need to remember that less than 0 means what? Negative. Less than 0 means negative. So that means there's a quadrant out there that when you draw your triangle, secant and tangent are both negative. Now, I know it's not going to be quadrant 1. If they were both positive, it would be quadrant 1. But it's not going to be quadrant 1 because I got negatives. So pick a quadrant. Joshua?
Quadrant
3? He says, let's take a look at quadrant 3. We're trial and erroring here, guys. So in quadrant 3, I know that's negative, and that's positive. Would everybody agree with me? Remember, the hypotenuse is always positive. So here's my angle. This is opposite, adjacent, hypotenuse. What is secant? Reciprocal of cosine, which means it's hypotenuse over adjacent. All right, let's look at our picture. If I put hypotenuse over adjacent, will that fraction be negative? Yep, that works. All right, now tangent. What's tangent? Opposite over adjacent. So if I put opposite over adjacent, will that fraction be negative? Kids, what's negative over negative?
Positive.
Yeah, that doesn't work. So it's not this quadrant. Okay, pick another one. 2. I'm gonna draw another picture so it doesn't get too confusing. So here's my angle. In quadrant 2, I know this one's negative because it's left. That one's positive because it's up, and hypotenuse is always positive. So this is adjacent, opposite. All right, secant, hypotenuse over adjacent. Will that be negative? Yep. tangent, opposite over adjacent. Will that be negative? There it is, there's your answer. There's only one quadrant that works. So as soon as you get matches, you're done. That's it, that's the one that works. What if 2 hadn't have worked? Then it would have to have been 4, because that's all that's left. I know it's not 1. 3 didn't work. If 2 also didn't work, then I would know it didn't work. Okay? All right, what else? Come on, we got time to do some more. Let's do it. What else do we need to do? Yeah. 7. Which one? Oh, 7C? Okay, 7C is a graph. Even if you are completely clueless about how to handle graphing this, you get a point for just having the shape right. So this is a cosine. What is the shape of a cosine? Starts at the top of the hill and comes down like this, right? Unfortunately, this one has a negative, which means it won't start at the top of the hill. It will start at the bottom of the valley because it's upside down. Okay, so it's going to start down here. So there's half my valley, my hill, and the other half of my valley. Remember that you're going to stop drawing your cosine when you get back to where you started. So we started at the bottom of the valley. As soon as I get back to the bottom of the valley, I'm done. Don't draw any more. It wouldn't be wrong if you did, it just might confuse you. All right, so there's a point. Now, I need to label the high and the low here on the vertical. I need to label where I cross, and I label where the peak is, and of course the end. So, look at your numbers in the problem. Tell me what you know. What do you know about these two labels? They're 1/2 and -1/2. Because the amplitude of the picture is 1/2. Okay, now we need to do our horizontal labels. Okay. There's a reason I don't teach freshmen. Okay. What have you decided?
They will be divided by 2.
Well, they're supposed to be, normally, these would be the labels. Like in the picture you memorize, your BFF, these are the labels. But in this problem, they have all been divided by 2. So we're gonna start with 45. Now, you can literally do this division all the way down the line, like I did 90 divided by 2. You can do 180 divided by 2, 270 divided by 2, or, if it's easier for you, you can say, okay, if this is 45, this is gonna be another 45, so add 45, add another 45, and add another 45. If division is easier for you, divide. If addition is easier for you, add. The answers will be the same. What's my period then? My period is 180 degrees. All right, RJ, what do you think about that? Is that okay? All right, let's do another one. You can do whatever word problem you want to do. Your test has 3 of them on it, so something's gonna be sitting on something, looking down at something. Do you have a preference? C? So C is an airplane looking at an airport problem. Every time we do one of these word problems, we have two numbers and an X we have to deal with. So, where does the 4,500 go? I'm looking at problem C. Where does the 4,500 go? Above the ground. That's like, he's not in a tree, obviously he's an airplane, but that would be like the height of the tree, right? How high up is he? 4,500. All right, where's the 16.3 go? That's my angle. How far is the airport from the point on the ground directly beneath the plane? So isn't this the point on the ground directly beneath the plane? And that's the airport? And I wanna know how far apart they are. Isn't my X there? Now, last time we did this problem, the question was, how far is the plane from the airport? That would be this, right? This is how far is the airport from the point directly beneath the airplane. All right, sine, cosine, or tangent. Tan 16.3 equals 4,500 over X. How do I solve this? Multiply by X. So X tan 16.3. Remember, I never mess with my numerator. I have to move the denominator. So whatever it is, whether it's an X or a number, it's getting moved to the other side. Now, because I need X by itself, I'm going to have to divide in this problem. I don't always have to divide, but this time I do. So the answer is $15,388.80 feet. Ed, Jenny, does that make sense to you? All right. If you have anybody, I can't remember who's been on. If you've been on retreat, you